Good morning, everyone. Myself, Vimal Chandra Sharma, joined as Assistant Professor in Department of Civil Engineering, Vidyavardhak College of Engineering. I'm here to teach construction materials and management as part of the GATE coaching. So let's move with the things I'm going to teach, or I will be covering for this GATE coaching. So there are a few things we have to. I'm looking to cover for as per the GATE coaching, right from starting from the concrete, structural steel, about brick, timber, and management, planning, and cost estimate. So today, I'm going to start about the concrete. So we will be looking at about concrete today. So, as per the GATE 2022, construction materials and management. So the questions was relevant to concrete. When it comes to the concrete, constituents of concrete, mixed design, short-term and long-term properties, and focused on structural steel, composition, material properties, and behavior of the structural steel. As part of the construction management, types of construction projects to be covered, and project planning and network analysis, PERT, CPM, and cost estimation. So this was the goal for the GATE 2022 GATE 2022 coaching. And when it comes to 2023, as you can see, as per the weightage, we can also cover the similar way, or we can add as per your suggestions. I welcome to take your suggestions as well as I want to add accordingly. So when it comes to the subject's weightage, so right from the 2012 GATE 2012 to 2020, if we see the GATE question papers for the civil engineering students, so most of the questions were asked in recent 2020 were from the geotechnical engineering as well as geomatics engineering, which was quite unexpected this time. But if you see the structural engineering related disciplines, structural such as structural analysis, RCC, steel structures, construction materials and management. So it is more or less covering more than 10% to 15%, even solid mechanics including. So it plays a major weightage in the GATE question paper for civil engineering. When it comes to construction management, so construction management and engineering mechanics, so it was a new subject from 12 to 2015. When it comes to 2016, the question paper came with 5% weightage of construction materials and management being a new subject. And gradually the percentage has been decreased from 5% to 0.5%. So the weightage to this subject, or the preparation towards this subject, uh, should be taken very care, and allocating time according to with respect to the other subjects should be justified properly. Yes. So the topic today is I mentioned the concrete. So basically, I want to go with the introduction to the construction materials. As you can see, it- building materials plays a major role in the construction industry, right from the extraction of the material, preparation of the material, testing of the material. It plays a major role in construction industry. As you can see here, a video, a graphic, a GIF image is showing so how this construction activity and how much emissions due to building materials are happening, and whatever the materials we can see, the different materials, right from the reinforcement as well as stones, as well as bricks, as well as some concrete or mortar preparation and steel and whatever the timber, wood. So these are all the very popular building materials we use for the building construction. So the concrete. So what is concrete? Concrete is a building material. It's a mixture of fine aggregates, coarse aggregates, as well as cement and cement paste when it is with cement paste which is having the water content. So the cement preparation, one of the major constituents of the concrete is the cement. The cement has undergoes with two processes. One is dry process as well as wet process. So when we see dry versus wet process, the dry process is basically it requires raw materials are very strong and hard during the dry process. When it comes to the wet process, raw materials are soft because complete mixing is not possible unless water is added. So the basic difference between dry and wet process is basically the amount of water, or the water itself is one of the constituents in the wet process. So when it comes to the raw materials, dry process, raw materials are changed to powder form in absence of water. So in the dry process, there is no water is added, and the raw materials will be changed to powder. So in the wet process, raw materials are changed to powder from in the presence of water. So as I mentioned, the simple difference is the wet process, the constituent is water. So for the dry process, dry process constitutes 74% of the cement, or 74% of the cement can be produced during the dry process, whereas wet process, it 26% of the cement can be produced. So where in the dry process we don't add the water. So because of not adding water, so the energy or less fuel will be required to complete this process. When it comes to the wet process, so we require high fuel requirements, or the fuel is required because as long as we are adding the water based on the cement, the amount that we are looking for. So whatever the water added, that should be evaporated. So for that, the fuel is required to forcefully evaporate the slurry water. So this dry and wet process basically is part of concrete preparation. So it comes to the cement. So now one of the important aspects of the cement is to follow the Indian standards or IS codes. According to the IS codes, say there are few rules and regulations that to be maintained when we are looking for, or when we are selecting or talking about particular cement. So right here we can see some of the cement, that is 33 grade OPC conforming to IS 269. So that means, so if we take the OPC is ordinary Portland cement, so that when it is when the water is added, so for after the 28 days, the cement has to maintain 33 kilo per the compressive strength should be maintained is 33 kg per Newton per mm square. So in the similar fashion, 33, 43, and 53, these are the cement types according to the IS standards to be taken. And apart from that, rapid hardening Portland cement conforming to 8041, Portland slag cement conforming to IS 455. So these are the cement types that we usually go for during the construction process. So fly ash based conforming to IS 1489, and calcinated clay based conforming to 1489, and hydrophobic cement conforming to IS 8043. So calcinated is basically the calcium, or the lime part will be playing a role here, and hydrophobic also one of the type of cement conforming to IS 8043. Yes. When it comes to the cement chemical composition, so there are majorly seven constituents in the cement. So in the concrete, again, we are talking about the cement. Cement has, again, a major role. That means during the preparation of the cement, so we have to see the percentage of the constituents, and we should make sure the percentage is maintained properly. So right from lime, that is calcium oxide. So the average percentage it should be included 63, and the percentage it can vary from 60 to 67%. So as you can see here, the lime is a major constituent of all the chemical composition of the cement. So after that, silica, that is silicon oxide. So that is 17 to 25%. Though as on the average, it should be 20%. So in the after that, the third major constituent is alumina. So that ranges from 3 to 8%. On the average, it should be 6%. And the similar fashion, iron oxide is basically 0.5 to 6%, and it is the average 3%, and magnesia also 0.1 to 4%. That is, on average, it should be 2%. So after that, sulfur trioxide, that SO3, so it constitutes of less percentage, that is 1 to 3% on an average 1.5. And soda potash is the mixture of Na2O plus K2O. That is the average of 1%. So the percentage that should range between 0.5 to 1.3%. So in detail, if we look at the cement chemical composition, so here the table you can see here the chemical composition, chemical formula, and percentage that when during the mixing of the cement. So when you see the chemical composition, so the first thing is tricalcium aluminate. So that is C3A in short, and you can see the chemical formula also here. That is 3CaO Al2O3, or shortly we can call it as C3A. This is during the earlier stages of the cement preparation. It will be formed. So it ranges from 8 to 12%. And the next stage is tetracalcium aluminum ferrate. So that is 4CaO, Al2O3, and Fe2O3 are C4AF in short form. So so the percentage of this chemical composition varies between 6 to 10%. Also, tricalcium silicate, that is 3CaO and SiO2 are C3S. C3A and C3S are those two plays a major role in uh, the heat when the cement during the hardening process. So it also ranges between 30 to 50% of the cement during the cement preparation. And dicalcium silicate, that is 2CaO and SiO2. In short, it is C2S. The percentage ranges between 20 to 45%. Yeah. So when it comes to the primary chemical composition, that is tricalcium aluminate. So the tricalcium aluminate, as I mentioned, 3CaO Al2O3 are in short C3A. So the time it will be formed is within 24 hours when the water is added. So it is as you can see and understand, this is an earlier stage of the cement chemical composition, that when the water is added to the calcium, so the reaction with the water and the calcium will be it generates a lot of energy, and that is why this is a fast reaction. So within 24 hours the it will be the tricalcium aluminate or C3A will be formed. So it is highly responsible for maximum evolution of heat of hydration. So as I mentioned, during the initial stage, when the water is reacting to the calcium, so we can see the maximum heat or energy will be produced during the process of during the chemical composition, that is the tricalcium aluminate formation. So the very next one, the second part, that is the tetracalcium aluminum ferrate. So that means that is 4CaO Al2O3 Fe2O3 are in short C4AF. So this is also a part of the initial phase or induction phase. So it will be formed within 24 hours of addition of water. So this is also high heat of hydration in initial periods. So this is also the calcium when the tricalcium or tetracalcium aluminum. That means when CH and O, if that is a combination. So in that combination, when there is a when the C and H is mixing with the C and A is mixing with the water as well as it is under the oxygen. So it creates a lot of energy or heat during the initial periods. So the next one is the tricalcium silicate, that is tricalcium, that is 3CaO SiO2R, in short form C3S. So it is basically the tricalcium silicate is after the two chemical compositions. I mean, after the formation of tricalcium aluminate, that is 3CaO Al2O3 or C3A, as well as tetracalcium aluminum ferrate, that is 4CaO Al2O3 Fe2O3 or C4AF. So it takes the formation of tricalcium silicate takes little more time when compared to the 1 and 2 chemical composition. So it takes time within 1 week, and it is responsible for the initial strength of cement. So when it is, maybe we can tell that, so it is responsible for the initial strength of the cement during the during the uh, acceleration stage of the concrete preparation or cement preparation. So it contributes about 50 to 60% of the strength. So as you can understand, C3S, the formation it should be very important stage, because it contributes about 50 to 60% maximum strength of the cement. So again it the content increases for prefabricated concrete construction. So this will be more the content increase for the prefabricated concrete construction. So this is most suitable at the cold weathering construction, or it is slowly whatever the cement or the whatever the chemical composition is not so easy to be liquefied, or when the heat interaction is there, so it will resist the heat, or even during the cold weathering condition also, this chemical composition plays a major role in the cement. And the fourth one is dicalcium silicate. That is, dicalcium is in the name 2CaO SiO2 or C2S. So, as long as we are looking, we have been looking from the tricalcium, tricalcium aluminate, tetracalcium aluminate ferrate, and tricalcium silicate and dicalcium silicate. So as you can see here, the silicate part, calcium part, and aluminate part is playing a major role in this the chemical composition of the cement. So as long as you see from the tricalcium, tetracalcium, tricalcium silicate, so from aluminate to the silicate process, the time it is increasing. That means the hydration process, or the heat that generating, or the energy that is generated during these three stages. So it is the time is increasing. As long as the time is increasing, the chemical composition is showing that the rigidness, or the due to the composition, the chemical composition, the cement is taking the strength. So when we reach to the dicalcium silicate state, this is the last compound formed during the hydration of cement. So this is responsible for progressive latter stage of strength. So during the acceleration, so we will be covering in the next slide. But however, I have to bring this. So during the acceleration state or deceleration state, so this C3S and C2S composition plays a major role, and finally it will be responsible for the chemical composition of the cement to be stabilized at some place and maintaining the steady state of the strength. So in this, some of the points related to structure requires later stages strength proportion of this component increase. So So basically, due to this composition, what is basically the benefit is that structure requires latter stages. Usually, when we apply the concrete, then the structure requires latter stages strengthen. The later stages, like after few days or few weeks. So the chemical composition helps to strengthen the building components or wherever the concrete is applied. So this is the essential ingredient in Portland cement. So this is one of the essential ingredient, and one of the examples we can of this composition. So hydraulic structures and bridges where this chemical composition of the cement plays a major role in preparation in construction of hydraulic structures and bridges, because they have to sustain for long. Due to this chemical composition only it is possible. So, to summarize this, the cement chemical composition as basically four. It includes the four compositions, that is tricalcium aluminate, tetracalcium aluminoferrate, tricalcium silicate, and dicalcium silicate. So here the short forms and the percentage you can see, and the tricalcium aluminate during the initial stage, and tetracalcium aluminoferrate also initial stage. So it gives a initial strength. It generates a heat, and it gives the initial strength to the cement, and later on the tricalcium silicate, it takes a few days but within a week, but it plays a major role in that, contributes 50 to 60% of the strength to the cement. Then this as actually why this is important, because at this stage we discussed about the cold weathering construction, and it also plays a major role in tackling with heat. So this is the third stage, and the final stage is dicalcium silicate. So as I mentioned, dicalcium silicate is a last stage or last compound formed during the hydration of the cement. So it is basically, it indicates, or this composition basically talks about the progressive later strength to the structure by adding this whatever the chemical composition and the percentage related to it. So basically, it's a essential ingredient in Portland cement, and one of the examples we can see is hydraulic structures and bridges, where this composition matters a lot. Yes. So we will be moving to the next one. So there are, so as this slide, the animation of this slide is showing about when the concrete is mixing with water, or when the concrete mixed with water. So basically what happens? So as you can see here, there are four pictures in this slide I have shown. So here, the picture is talking about the induction periods. So induction period is basically when the calcium uh, so this is basically related to the hydrating cement cream. So when it mixed with the calcium as well as the aluminium, when CH is mixed with water, so immediately it forms something. So that is ettringite. So that is basically when the when C and H mixed with water in the presence of when the oxygen when it is burned during the burning process, so the attringent formed. So during this process, lot of energy will be produced or heat will be produced. So as you can see here, so attringent, so it is formed when the cement is mixed with some water particle. The CH, the bond between CH and water. So this is a process of attringent. Then the next phase is like acceleratory periods. So acceleratory period is basically, so when C, S, and H, that is the chemical composition of C, that is calcium, that is silicate and hydrates. So when calcium, so when these three are in the presence of oxygen, so again the lot of energy will be produced, but less than during the induction periods. So the acceleratory periods, that means in the name itself, the heat will be generated due to this CSH composition. Then it will continue up to some time. So as you can see here, so the attringent will be formed, and because of this composition C, S, and H. So after that deceleration period, so that is basically uh, after some time, the C and H as well as C, S, and H composition. So basically, most of the cement composition will be hydrated, or it will be out of this CH and CSH. So that is why the energy will be, I mean, the composition of CH and CSH will be reduced somehow, and then the energy will be decreased, so that you call it as deceleratory periods. Again, it will continue. This deceleratory period will be continuing for some period, for few days or few hours. Then finally, it stabilizes at some place. Then we call it as steady state. So that means at this stage, at the deceleration period stage, so the maximum strength of the cement will be achieved, and it will continue. Then we call it as the uh, uh, steady state. So yeah, we will see how much amount of energy will be released during the four stages. So in the next slide. So here, as you can see, this graph is between the time as well as rate of heat generation in the energy, that is watt per grams. So here, as you can see here, there is in the last slide we discussed about various stages, that is induction as well as acceleratory, deceleratory, as well as period of slow continued reaction or steady state. So during the initial reaction, why this energy, the red line shows the increasing or the decreasing in the energy. That means watt per gram. So heat generation, that means basically we are talking about the energy. So the rate of heat generation is nothing but how much rate. So with respect to the time, how much watt per grams is released. So when you see at the initial stage, right from the 0 to, for example, 13, I mean, 13.5 or 13.8, whatever the energy is has been released during the initial reaction. So that means lot of energy has been released because the water is just mixed with the calcium constituents. So because of the reaction with water and calcium, so the reaction, because of that reaction, lot of energy will be produced, and eventually that will be not that will be suddenly dropped, and again during the induction period it will be slowly increased, but not more than the initial reaction. So the induction period, basically it takes within the 24 hours. So as I mentioned, so within the 24 hours or within few hours, it will be taking again it will increase, again it will increase, because that increase we call it as acceleratory period. So in the acceleratory period, the incremental in this energy, because of CSH composition, and when it is reacting with water as well as the oxygen. So it will again remain for a few hours, for example. So the induction period is basically this part. So let me just show it with the pointer. So basically this induction part, so this will be up to some period from here to here. Then the induction, after the induction period, so it is taking almost, let's say, 1 to or 2 to 6 hours. That means approximately 4 to 5 hours, or we can say 3.5 hours to 5 hours. So the acceleratory period where the peak energy is between around 4 hours. So basically, or after 2 hours, that means 2 to 6 hours, in between 4 hours. So after 2 hours, so it is taking the peak. So this acceleratory period, as I mentioned, it is basically due to the composition of the cement from C, S, and H, and water as well as the oxygen. So after the acceleration period, so during the deceleration period, the composition of CH as well as CSH will be decreased somehow due to the initial reaction, induction period as well as acceleratory period. So it will contribute a lot in generation of heat. Then the cement or the chemical composition will be reduced somehow. Then during the deceleration period, so it will be decreased from, let's say, 7 hours to some 12 hours, or we can consider, 12 hours, or nearby approximately 12 hours. So after the 12 hours, we can see more or less it is the decreased as, or after 18 hours or after 17 hours or 15 hours, we can say. So it will gain a steady state. That is period of slow continued reaction. After some time, this whatever the strengthen or heat hydration will be stabilized after some time. So after that, so this is basically the rate of heat generation when the cement during the cement preparation. So how chemical compositions of the four chemical composition plays an important role in the aspect of heat, or in the context of heat or reaction with the water. So the next slide, the slide basically shows the chemicals for superplasticizers. So what is a superplasticizers? So the superplasticizers are nothing but uh, the material that can reduces the water. So it's a additive to the chemical composition of the cement. So why these super plasticizers are important? As you can see here, so the cement flow, that means the viscosity of the whatever the cement the paste we are applying. So it's all about how much viscosity, or uh, the relationship between the each and every particle of the cement. That is, whatever the water that is trapped inside the in between the cement paste. So that will be maintained properly when we add super plasticizers. So it will reduce the water. So it's like when we add, the water will be released, interplastic repulsion will be taking place, then the water will be released. So the trapped water will be maintained or properly when we add super plasticizers. So these are usually what? So these are usually some of the super plasticizers are the sulfonated melamine formaldehyde. That is, in short, we call it as SMF, and sulfonated naphthalene formaldehyde, that is in short SNF, and modified lignosulfates, that is MLS, and polycarboxylated ethers, that is PCE. So these are nothing but the super plasticizers to maintain the to reduce the water, excess water or trapped water in the cement preparation. So release of trapped water from cement flocks by the action of superplasticizers mineral admixtures. So as I mentioned, this is a additive. So some of the additives are like fly ash or pulverized fuel ash, that is PFA. And the other one is silica fume or microsilica, and the rice husk hash, and ground granulated blast furnace slag. So that you call it as GGBS, and this is very popular. And metakaolin. So this is about the chemicals for the super plasticizers. So this is a chemical semi chemical for the super plasticizers, that The superplasticizers can involve these chemicals, and these are the examples of cement flake, the release of trapped water from the cement flocks by the action of superplasticizers mineral admixtures. So these are the things will be utilized for as a superplasticizers during this for the cement paste preparation. So yes. So to summarize the today's class, so I will go through quickly again. So what we have seen today. So I started with concrete. As I mentioned, concrete is a combination of fine coarse aggregate, cement. So and water. So the cement basically undergoes the cement. There are two processes. Cement will be prepared, that is dry and wet process. So in the dry process, in short, the 74% of the cement is produced, and during the wet process, 26% of the cement will be produced. So during the dry process, the less fuel requirement will be there. When it comes to the wet process, the high fuel requirement is there. So when it comes to the cement, so we have several types according to the Indian standards. So as you can see here, so I mentioned 33 grade, 43 grade, 53 grade ordinary Portland cement. So which has the compressive strength of 33, 43, 53 Newton per mm square after 28 days. So again, rapid hardening, Portland slag, fly ash, calcinated and hydrophobic cements are just conforming to the respective Indian standard codes. Then the importantly, cement chemical composition, basically seven constituents are there. So right from lime, silica, alumina, iron oxide, magnesia, sulfur dioxide, soda, and potash. So the maximum is lime, about 63 average, and ranges between 60 to 67%. So this is a major. And the silica is the next one, 17 to 25%. So that is why these two are the main chemical composition playing in the strength of the cement, or when it is reacting with the oxygen or water. So the very least is soda and potash. It's about 1.1%, and sulfur trioxide is 1.5. So when it comes to the cement chemical composition, so this is one of the major aspects of the cement one should look about. So there are four compositions: tricalcium aluminate, tetracalcium aluminoferrate, tricalcium silicate, dicalcium silicate, and respective chemical formulas and percentage are there. So during the formation of tricalcium aluminate, so that is in short C3A. So tricalcium aluminate as well as tetracalcium aluminoferrate will form within 24 hours, and it causes a lot of heat generation as well as the energy. It causes releasing a lot of energy during the cement. Then the tricalcium silicate is the next part of these two. This is not the immediate one, so it will be formed within the week. And you can see here, it also responsible for the initial strength of the cement. It contributes 50 to 60% of the strength, and it can overcome with the harsh weathering conditions, or during or harsh weather conditions of construction phase. Then, so again, the dicalcium silicate is a last phase. So this is a last form during the hydration of cement, and responsible for progressive later strength. So it's a on the long term. So this chemical composition plays a major role. So it is one of the essential ingredients of the Portland cement. So we can see the hydraulic structures, bridges having this composition plays a major role. So the next slide we also discussed about. I also discussed about the different phases of when water is just reacting with the concrete. The cement. So during the induction period, so how this CH bond or attringent will be formed, and how this CH bond during the induction period contributes to the energy as well as the so when it comes to the acceleratory periods, so it will be accelerated in terms of energy when it comes to CS and H, the chemical composition. So the next stage is deceleratory periods, that is the deceleration stage, where CH and CSH chemical composition will be the complexation will be reduced. So that is why the energy released, the rate of energy will be reduced. So after the stage of deceleration, the steady stage will be achieved, where the strength will be maintained, or the paste of the cement will behave on the similar fashion with respect to the time. So in the this is one of the important aspects we can consider. So this talk about I mentioned that this is a rate of heat generation in terms of watt per grams with respect to the time. So that is why it is rate. So when it comes to the initial reaction during the chemical composition of the cement, then when water is added to the ingredients or constituents, so that lot of energy will be released, and after the induction period or after the initial period, that is this portion, so the induction period will be started. Then the still whatever the heat is reduced during the induction period is also it also it also part of initial reaction or immediately after the initial reaction. Then the acceleratory period due to CSH bonding and the water as well as the oxygen, then it prolongs for at least 4 to 6 hours. Then the deceleratory period will be pronounced, where the chemical composition or the complexation will be reduced. Then it will achieve steady state after the 18 hours or 16 hours. So in the final, the chemicals for the I also mentioned that superplasticizers, that is the chemicals for superplasticizers, those are sulfonated melamine formaldehyde, that is SMF, and sulfonated naphthalene formaldehyde, SNF, modified ligneous sulfates, MLS, as well as PCE. So these chemicals play a role in when the cement flock, that is the trapped water that is changing the viscosity. That means the water, the paste is not, if the paste is not maintaining certain viscosity, then the trapped water will be managed well by adding this superplasticizers. So here you can see how this water will be released. So the interparticle repulsion will be there, then the water will be released. So this is basically the chemicals for plasticizers. And again, so this will contribute to release of trapped water from cement flocks by the action of superplasticizers mineral admixture. So as I mentioned, this is a additive to the cement to manage this whatever the trapped water and majorly viscosity. So I mentioned that some of the materials like fly ash, silica fume, and husk ash, and ground granulated blast furnace slag, that is GGBS, and metacoulin. So this is basically about the concrete and how the what is concrete as well as what is the composition of the concrete. So I mentioned cement and some of the coarse fine aggregates as well as uh, water. So how the concrete will be prepared? What is the chemical composition of the concrete? So I hope this lecture will give better information for the further preparation of related to the concrete and the chemical composition as well as cement preparation. So in the next lecture, we will be looking at the bricks and soil, as well as materials related to bricks, soil, as well as the timber as part of the skate preparation. So I hope you enjoyed this lecture, and I'll meet you in the next class.